In this video, we're going to talk about indirect addressing. If I wanted to specify a full name of what exactly we're going to do, I need to probably add another statement right between the indirect and addressing and call it indirect data memory accessing. So this only relates to data memory, okay? And what it is basically an ability for us to be able to decide in the program while it's running, based on the input and the events that are happening, which address we want to access, and be able to automatically increment, automatically decrement, or have a base with the offset from it to access. So those are the things we really like to do, and that's why we have indirect addressing. Indirect addressing is used anytime you want to move a block of memory. You don't want to be sitting down and writing the specific addresses in your code, hard-coded in your code. You want to be able to programmatically create create a list of locations and move data from one location to the other without having to upfront specify where you want to move it from to. And that's where the indirect addressing becomes very, very useful. Actually, to be exact, without indirect addressing, you are not able to dynamically in your program decide, hey, now I want to move this large chunk of memory from here to here, or I want to automatically increment or decrement my address. You always have to know that when you're writing the program, which location do you want to move to what location. So what are the different ways that an indirect addressing could potentially be used? Well, indirect, if you got a data memory, you may want to put in a register. Usually this is called the base register. In the case of PICmicro, this is referred to as FSR. And since they have multiple indirect addressing systems, they usually put a number here, 0, 1, 2. They have 3 of them in the particular PICmicro we are looking at. So this could be FSR1, FSR0, FSR2, some number here, we'll just call it N, which can be less than or equal to 2, larger or equal to 0. So those are the 3 steps it can take. And they could be this is 16 bits, so you got a high and you got a low, and this could be looking at any location in the memory. Anytime I access memory, I do moves, adds, any operation that either needs to read the data or write the data can use indirect addressing and can affect the indirect addressing. I could directly look at a location, write to it, read from it, and that's fine using this base. Instead of giving an actual address, I just write where I want to look at in this FSR register, and the next time I access it, it does that. And then I also could set it up so when I read this pointer automatically gets incremented to the next one. I can set it up so it can automatically decrement to the previous one, or I can set it up such that it takes whatever is in this register, add it to whatever I have in W register, and then the result of that is used to look at the location in memory. Those are different options that you have with indirect addressing. And not only as a programmer you have need for that, compilers won't, and modern systems could not operate without having the indirect addressing ability. For example, when your program is compiled and is an executable is created, you never know where in the memory it's going to be loaded, and furthermore, you don't know where is the memory, data memory allocated to you. All you know is where is the base of the address, which this indirect addressing worked perfect because you put the base in there, and then you can start using the memory from there forward. Compilers for most processors make heavy use of indirect addressing because they don't know where the data memory is when they get loaded into their executable gets loaded into the memory of the computer to run. Okay, now let's get a little more specific and talk about how about this system. As I mentioned before, we have the one FSR that could point one place. We have another independent, there are three independent addressing system. Another one is called FSR0. I have one already, FSR0. It's completely independent of FSR1. It can operate on its own and do its thing. You can also have a third one, which is FSR2. So, and all of these are 16 bits, 0 to 16, and they are referred to as the high and the low side, FSR high. So the actual address is FSR high 2, FSR low 2. That's how you write it to them. Or you can use this instruction. There's a special instruction called LFSR. So if you want to write, for example, to FSR 0, I'll just say LFSR 100. 0, 100, and it take 100 and put it in FSR 0, so from then on, and I can do that with FSR 1 or FSR 2. Let's go ahead and take a look at some specifics here of what I've talked about. In the particular case of PICmicro that we are using, so you have three systems that you can use. We got the independent addressing system 1, system 2, and system 3. They are equal to each other. Sometimes you need to have three independent running so you can move from one to the other without having to rewrite it. And we'll see some examples of that shortly. But each one of them are capable of being set up using LFSR. Then what you could do, you can use, if anytime you access this register, is simply accessing a location pointed to by the FSR 0 in this case, or 1 in this case, or 2 in this case. And if I use post decrement, if I write to register post decrement 0, what it's going to do is going to decrement after writing or reading from FSR 0, it is going to decrement FSR 0 by 1 byte, 1. Post increment, of course, does the operation read, write, and then it's going to increment the FSR 0 by 1. And then pre-increment, what it does is before it does the access, it does the increment, then it does the access. And the pulse plus W, what it does, it takes whatever is in FSR 0, adds the W register to it, and access the location that is pointing, that sum is pointing to. It will not change, just it's important, it will not change FSR 0 in any way. Okay. Now, everything I've said about FSR 0 also applies to FSR 1 and to FSR 2. So you can do the same thing for all three of them. They're equally capable. There is really no difference between the three indirect addressing subsystems. Now, let's go ahead and put this in practice and see if we can kind of get a good feel for what is going on. Let's say we have a memory. And I'll take these one at a time. Let's say initially we come up and said LFSR, load FSR, and we're gonna say, and I'm gonna use FSR 0. You can just replace the 0, 1, and 2, and it would be exactly the same thing. FSR 0, and I'm gonna, let's say, put a 200 in here. Okay. So now but basically at this point, when that operation is done, we're saying, okay, then now my FSR 0, the base of my thing is looking at this location in memory. Okay, so if I read that location or whatever, this is this location, the address location 0x200 is where this indirect addressing is looking for it. Now let's look at it. Let's go ahead and see what happens. What happens if I were to move LW, I don't know, 0x36. And then if I do that, nothing's happening so far. But if I come in and let's say I would do add, actually let's not do add, let's move something in there. So let's say I do a move WF. So what does that do? That is writing to the location, and if in here I put in this one, INDF, INDF0. Well, let's see what it does. It basically indirectly addresses the location of FSR0, and it does nothing. So what it's going to do, I'm accessing it because MoveWF requires me to write this into the register. So what is going to happen, now this location contains X36. FSR does not move. It stays where it is. So that if you do not want your FSR to move, you just want to write to the location pointed to it, then you better use INDF0. Okay? Now let's say, yeah, that's great, that's nice, but I want to be able to kind of start at FSR0 and keep writing, and every time I write, I like things to go backward in this case, okay? So if that's the case, I'm going to do this. So now what's going to happen, I'm going to go ahead and do this. I'm going to say add WF, okay? And I'm going to do an add W, add has two Ds, I think. Let's say I do an add WF, and then I'm going to say, instead of using inc, I'm going to use the second one, which is post dec. So I'm going to use post decrement 0. Okay, and the line I put through it is not to get confused with, oh, that's all. So that's just saying decrement 0. So what is going to happen here? Well, and then let's say comma 1, so puts the result back in whatever post decrement is. So this, what is going to happen here? This particular instruction is going to read whatever FSR0 is looking at, fine. And then it's going to add whatever is in W register to it, which is 36 plus 36 hex, which is going to be 2 of them. So it's going to be 6C hex. And it's going to, because it's a post decrement, it's going to make sure that FSR is no longer looking at here, but FSR is pointing. So FSR value changes from 200 to 0x1, is that right? 1FF. So it goes back one step. Hopefully that makes sense. So that's what post decrement does. It does write to whatever FSR0 is looking at, and then it decrements it by 1. So what else do we have? Well, so post increment is the opposite of that. So this is kind of the beauty of this. So let's say I decide that that's great, but I want to change that 6C and do so. If I use any kind of instruction with post increment, what it's going to do is going to basically change FSR after the operation. So let's use a different color. Let's use a green, for example. And if I come here, let's do. This is kind of getting boring, but let me do this. Let me just do a move LW, so we get a diversity of numbers, and this says 0x20, for example. And this time, instead of using post decrement, I'm going to use post increment. Okay, and 0. And what I'm going to do here is I'm going to do move WF. You can use any instruction that access that location, but for lack of creativity, I keep using those same ones. But anyway, move WF, what it's going to do is going to come over here and says, oh, he's looking over here, so let's get rid of this and put 0x20 in here. And then after we're finished with the operation, let's bring the pointer back. So it's going to increment the pointer back to 0. But notice it's happening after it, okay? Now, let's do one more. And this, so now we got 20 in here, we got 36 in here. If you happen to do another move, WF, but this time you do a pre-increment. We already did, so pre-increment. What it's going to do, the only difference between post-increment and pre-increment is that what it's going to do is going to move whatever is in W register here. So it's going to make this 20. And after it's finished, it's going to move this FSR0. Now, after we have done this instruction, FSR0 is looking down here. Okay, that didn't change the location, so did not change location 0x201, but because we did that, we're there. Now, another one we haven't talked about, let's say you decide that's great, and now I want to do a, I want to move whatever is in this location, whatever is in here, let's say, I don't know what is in here, but let's say it's EC in here, 0xEC is in this location. So, but I want to move that, I don't want to change my FSR, but I want to move this, this whole thing, I want to move it to this location, 0x2F0. Okay? Or let me make it a little easier, so F1. But I do not want to change my FSR, and then this would be a useful tool to have. Let me go to black, back to black. So instead of using post-decrement, and all of that, what I could do, I could say, oh, why don't we do that? Why don't we do move LW, and we're going to put the difference in here. So the difference is going to be F0, 0xF0. So I'm going to put that in W register. Then I'm going to say move, right, FF, and I'm going to move, since my FSR is over there, I'm going to say move from INDF0. Remember, that does a nothing, comma, and I'm going to do this last one, plus W register, plus W0. So now see what's going to happen is that, oh, FSR is looking over here, so it's going to do INDF, which means I just go look there and pick that stuff up. Don't change it. Don't change the FSR. Don't do anything. And then find out what value is in W register, which is F0. Add it to my current location, FSR 0. So that's going to bring us down here. So this is basically FSR 0 right now, plus W register, this location, and then move it there. So what's going to happen is that 0xEC is going to be put in place. FSR didn't change. FSR still is pointing at 201. Okay, let's go back and recap this before we go to any more examples or anything else. So we got these we've got these indirect addressing systems, and they, depending on whether you write to INDF, post-decrement, post-increment, pre-increment, plus W, it will do different things and changes the FSR or doesn't change the FSR depending on what happens there. Now, everything I've said again about 0 applies to the 1 and the 2 systems as well. Now let's go ahead and take a look at a little more a code that is a little different. So let's see what this code does. So first thing it does, it says, okay, you're looking at the memory. Oops, this memory's got a little bent edges. And so it initially starts with your FSR 0 looking at location 100. That's this instruction. And then it says set F. What does set F do? Set F makes a register to all FFs, right? So it says set F post increment. So now what's going to happen here? So let me take a different color. Let's take a red. So what it's going to do, this is going to say, okay, because it's accessing this location and writing 0xFF, because it's set F, all the register gets set to 1, all the bits in the register get set to 1, but it's a post increment, which means the next time next time you write using FSR, your FSR is not going to be looking at here, it's going to be looking right here at 101. All right, and then you're going to do a bit test FSR high. What does that mean? That means right now you're at a 100. I want, basically, if you think about it, I'm going to expand this out so you can kind of see. FSR has 2 bytes, right? When it's looking at 101, the register, if I write the bits out, is going to be 1, 0, 0, 0. These are all hex addresses, so I'm turning them into binary. And then so it's going to be 0, 0, 0, 0, and then it's going to be 1, 0, 0, 0 on 0, 0, 0. And what it's saying is go ahead and do this, keep sitting in this loop and turning until bit 1 of the high, which is really this bit, becomes a 1. So when is this going to become a 1? The first time this is going to become a 1 when we have this, right? So it's going to be 0, 0, 2. So what it's basically saying, oops, let me redraw this. This is our memory. It's saying go ahead and keep writing until this bit becomes a 1, which means you're going to write until and including a reading to location 0x200. So what's going to do is going to come all the way down here, and you're going to be writing FF all the way down here. And when you're finished, your FSR, I'm going to take this back. This location, actually, the highest location that is going to write to, the highest location is going to write to is going to be 0x1FF, because as soon as it writes to this location, FSR is going to be looking at location 200. And that, when he gets here, when he does the post increment, the FSR is already looking at the next instruction, so it's going to be at 200. It's not going to do loop back and do that. It's going to jump here and move on, branch to continue, and it's going to sit in infinite loop. So what you're going to have 0xFF from here all the way down here, and this is the little loop that will do it for you. Okay. Let's go get a little more interesting. So what would be some other things we could do with this thing? Well, a lot of the time this is a very useful tool to be able to take stuff from one part of the memory and write it, change the order, or do some other funny things with it. So for example, let's say you're being asked to take to move or copy. Let me say copy. Copy is a better term than move. So here's an example, and you want to write a code that copies content of memory location let's say 100 to 150 hex. So 51 location from 100 to not 50, 51 hex location to in reverse order 2050 to 2000 hex. So basically what it's saying, take whatever. So this is one location in memory, this is another location in memory. So we're basically saying take everything that is in location from 100 location and write it in 2050, and whatever is in location 150, write it in location 2000. So if you think about it, this is kind of this way, we're moving in this direction as we walk through it. Now, before we learn about indirect addressing, there's no way for you to programmatically do this unless you sit down and write all of those locations. But with using two indirect addressing, it becomes wonderfully easy to do this, because what I can do, I can start in LFSR. I'm going to start by LFSR and use my indirect addressing FSR 0 and write and set it to 100. So what did I do? I basically said, okay, FSR 0 is now looking right here at hex 100. and then I can come over and say, okay, now go ahead and LF, again another FSR. This time I'm going to use the FSR1, and I'm going to set that to 2050. So what did I do now? Well, I took FSR1 and I pointed it right there. Okay? So, great. Now what? Well, I want to copy in reverse order, right? So all I do is basically say move So first thing I got to figure out how many locations do I want to move and kind of have a count. So I could just say, okay, why don't we just do this? Why don't we, I'll use a black one or some other color. This has nothing, so I'll do move LW. And I say, okay, there is 51 hex location, or is not 51, but 51 hex location, because I go from 100 to 150, so that's 51 location. And same here. So I'm going to put that in there. Then I'm going to have a little loop. And what I'm going to do is, look, this is the pretty awesome instruction, which is what I'm going to do. I'm going to say move move FF, and I'm going to do post increment 0, comma post decrement 1. And this is a very innocent looking instruction, but it's a pretty powerful one. See what happens. The first time through this loop is going to write 150 to 200. I'm sorry, 100 to 2050. Oops, this has got to be I noticed that it's going to be 2050 because FSR1 is looking down here, FSR0 is looking up here. Now, when it finishes, what happens? When it finished, this FSR, when it's finished with the first instruction, this FSR is looking at 101, and this FSR is looking at 204F. That is the beauty of this. So as every step through the loop, FSR1 is decremented after the work is done, and FSR0 is incremented after the access has happened. And there you go. That's how you're doing reversing the order. And then what you're going to do, you got to stop at after 51. So all you need to do is to say, okay, decrement F W register. So you're decrementing W register, and until it's 0. When it's 0, you don't do it anymore. So branch not 0 through to loop. Okay, and this little piece of instruction moves the data in reverse order. And you can imagine using your newfound skills with this indirect addressing, you can do amazing things with dynamically deciding where you get the data, where you're going to send the data, and reordering it, and doing all kinds of stuff like that. This video ended up being a little longer than we like it. We like the videos to be between 10 and 20 minutes, so this is a little longer, but indirect addressing is a pretty useful and somewhat not that difficult to get a hold of, but you need to practice it to make sure you get a hang of it. I'd encourage you to try to write some sample code using all the variety of access that is available in indirect addressing. And simply by writing in these different names, you get to do different functions to the same location in memory and how the value of FSR changes.